Section 21.14 DD and charge transfer reactions. The photon-induced DD transitions involve angular redistribution of electrons. So that means when you promote electron from one d orbital to a different d orbital, its magnetic quantum number changes. The z component of the electron spin changes. One example is this. Hexaamine chromium 3. Its ground electronic state involves 3 d electrons, each occupying one of the 3 T2G orbitals, dxy, dyz, dzx. This transition metal complex may absorb a photon and promote one of the 3 electrons to one of the 2 Eg orbitals, either dz squared or dx squared minus y squared. And then in this process, the oxidation number of the transition metal center remains unchanged. This chromium 3 has a oxidation number of 3 before and after this DD transition. There are also photon-induced metal-to-ligand and ligand-to-metal charge transfer, MLCT and LMCT. They result in the radial distribution of the electron density. So either the electron flows from the metal to the ligand or from ligand to the metal. That will change the distance between this electron and the transition metal center. So that's why we say this is radial redistribution of electron density. And MLCT, electron transfer, will cause the oxidation of the transition metal center because the metal loses electrons. The LMCT will cause the reduction of the transition metal center because this metal gains electrons. So in these two cases, you have redox reactions that take place in this transition metal center and also in one of the ligands. Now, if the ligand has low-lying empty orbitals, and it's possible to observe the excitation of the electronic state of the ligand. For example, in this carbonyl ligand, it's possible for a pi electron to absorb enough energy to jump to a pi star antibonding orbital. So in this case, there's no change in the oxidation number of the transition metal center. All right, this is just a photo excitation of the ligand.